Good day, everyone. In this video, our group we're going to discuss about the chapter 3, 4, and 5 in this study entitled ANOVA to study movie premieres in the USA and online conversation in Twitter. The case of rating average using data from official Twitter hashtags. So before we're going to start, the authors of this research are Victor Yeste and Angeles Caldach-Losa. So the objectives of their research is first, this study is an exploratory study and quantitative and not experimental study with a scope of the movies that premiered on February 2022 in the USA. So using as the object of the study, the movies and the tweets that users published about them in the week immediately before, the same week, and week immediately after each premiere date. Before we will proceed, quick background about ANOVA, or also known as the analysis of variance. It is an analytical model that studies the statistical significance of differences, assessing the reliability of the association between one or more independent and discrete qualitative variables and a dependent and numerical variable. So, for a statistical analysis, ANOVA is frequently used with the Pearson chi-square test and independent t-test, but for different and complementary purposes. So, the next and the main objective of this research is to explore the use of ANOVA to look for relationship between average rating and usage, conversation, engagement, and amplification rates of official movie hashtags from movie premieres. So this study analyzes if ANOVA can detect interesting relationship between tweets characteristics and a movie's average rating. So in a simple word, they will test if using the ANOVA method, if makadetect ba ang ANOVA, if makadetect ba siya difference between the average rating and usage of a specific movie using a Twitter as their data collection base. So this study uses the movies and the tweets published about them as objects of study. So two different data tables have been created. So next is the data collection and the statistical analysis. So this paper will obviously focus on the application of ANOVA in the field of digital communication regarding movie premieres in the USA. So this has been done by using the official hashtags of the movies to avoid other uses of common titles. So Twitter is known for using hashtags so that you can track a specific topic or category. So in this case, hashtag sila nag-base i-collect nila sa data. So the objectives were already explained, and in data collection part, the movie analyzed in this paper have been the ones that premiered in February 2022. So their data has been collected from Box Office Moho. So it is a website part of IMDb Pro. It is also a site na mag-collect of data. So regarding Rahul Shah 2021, IMDb is one of the most well-known cinema websites with one of the biggest databases of movies on the internet. So the average rating variable was extracted from IMDb on the 2nd May of 2022, so more than a month after the latest movie premieres. In the statistical analysis, the main tool used for the statistical analysis has been a Jupyter notebook, including Python libraries such as Pandas and Seaborn, and a database on SQLite. So the initial step consisted of retrieving all data from the database and creating data frames to analyze it from each week's perspective, a generic data summary for each movie, and their Twitter-related data. And on the other hand, other data frames with the data limited to the week before, the same week, or the week after each premiere. So since this study uses ANOVA as an aim to look for statistically significant difference in the average rating using the information provided on Twitter-related variables. This means that the dependent or response variable is the average rating of each movie, so whose variability is analyzed with the variability of the Twitter data variables. So if a significant difference is detected, the Twitter variable analyzed could affect the average rating of the movie. Thus, the null hypothesis is that no statistically significant difference can be obtained by the ANOVA test. So choosing the most usual level of confidence of 95%, it would mean that the test can reject or not reject the null hypothesis with 95% of confidence, leaving a 5% of alpha or type 1 error that it can be mistaken because of a chance. So following this methodology to the proposed case study, every movie and Twitter variable has been tested with ANOVA, so not only from general perspective considering all data, but limiting the information to just 1 week at a time. Because they are continuous variable, they must have converted to categorical using the quartile. So, moto continuous man, so gayo sila quartile, which is the Q1 to Q4. So, Q1 as the first quartile or the 25%, Q2 as the second quartile, Q3 as the third quartile, and lastly, Q4 as the fourth quartile.
So let's go to the analysis of variance, ANOVA, result, and data exploration. So we're going to the results. So first, data exploration. So the first step of the methodology is to understand the data of the case study that is going to be analyzed. This data exploration can lead to the conclusion that ANOVA is not necessary because, for example, all movies has been released in the same number of theaters. So 36 movies released in the USA in February 2022 in 4 different dates. Considering the movies that have been published, that data, they had an open gross average $4,882,695, and they have been watched in a mean of 1,240.52 theaters in the week of their premiere. Twitter user published 389,639 tweets in the analyzed time between 28th of January, week before the first movie premiere, and 10th of March 2022, the week after the latest movie premiere. Movies showed an average of 10,823.3 tweets, 1,579,464 retweets, 31,489.67 likes, 2,382.53 replies, 819.89 quotes, and a sentiment analysis average of 0.39, where -1 is absolute negative and 1 is the absolute positive, which means that the opinion was more positive than negative in general. To further understand this work uses ANOVA to detect a possible significant difference in the rating average of the movie when considering the variability, the different values of each analyzed data variable. The objective of the study is to detect significant difference between the groups of each variable as a factor regarding, in this case, the rating average of the movie as a response variable. These analyses have been tested with 95% level of confidence, with means that the p-value must be lower than 0.05 in the ANOVA summary to be considered as a procedure of a significant difference. This study has considered the 25 of the 36 movies released that have published their opening grosses and number of opening theaters for these variables. So this table shows the ANOVA of the rating average with opening grosses as a factor. When analyzing with an ANOVA, the opening grosses as a factor, the result is a p-value of 0.28, which means that there isn't a statistically significant difference in the rating average of movies between different quartiles of opening grosses with a 95% level of confidence. So, this table shows the ANOVA of the rating average with opening grosses as a factor. When analyzing with an ANOVA, the opening theaters as a factor, the result is a p-value of 0.003, which means that there is a statistically significant difference in the rating average of the movie between different quartiles of opening theaters with a 95% level of confidence. So this is the table 3, that is ANOVAs of the rating average with every Twitter variable as a factor depending on the time it considers. So table 3 shows that there is a statistically significant difference in rating average of movies between different quartiles of tweet counts, reply count, and sentiment mean with a 95% level of confidence when considering all data from the 3 weeks. So, if only T1 is considered, most of the Twitter variables shows the significant difference of tweet, quote, reply, retweets, and counts, and retweets and like means. However, when only T2 is considered, only counts of tweets, quotes, and replies, and the sentiment means show a significant difference. Finally, if only in the second week of the premiere considered, tweet and retweet counts and like means are the Twitter variables with a significant difference, all with a 95% level of confidence. So, the progression of p-values with time is also different between Twitter's variable. So, variables such as quote count, quote mean, reply count, and like count show a p-value increasing with time, while almost all the others show a tendency to increase from the week before the premiere T1 to the week of the premiere T2 and decrease again from the latter to the second week after the premiere T3. So the only variable with a different trend is the sentiment analysis mean. It decreases strongly from T1 to T2 and there increases from T2 to T3 to the point of stopping being significant. The p-values with the maximum values are reply count T1, quote count T1, like count T1, and sentiment analysis mean, all with a p-value of less than 0.001, assuring a level of confidence more than 99.9%.
In this work, ANOVA has been used to test if there were significant relationships between the groups of values of variables related to movies and Twitter. The null hypothesis was that there weren't, rejecting that hypothesis if it is improbable that the differences between the groups are produced by chance and the groups are, in fact, different regarding the response variable. In the particular case study that has been used in this article, when comparing different quartiles of movie and Twitter variables about movie premieres and their average rating, some interesting relationships have been detected. If all data is considered, the variable that is more surely linked to average rating is the sentiment mean, only followed by the reply count and the tweet count.
The three of them are measures of the online conversation about the movies, how users are talking about them to each other by replying with their own posts, and the sentiment analysis of the post they send. Interestingly, when considering the 3 weeks of data separately, the week immediately before the movie premiere is the one that has a stronger relationship to the rating average, even if this variable is collected weeks after the movie premiere. All count variables and the means of retweet, like, and sentiment analysis are related to the rating average, which could mean that all the characteristics of the Twitter conversation about the movie before it's the main difference between variables collected before the premiere and the ones in the week after it is that the latter don't include retweets and likes, but only the ones about the number of tweets, quotes, and replies, and the sentiment mean about their opinions. As retweets and likes are ways of sharing information, it seems that only conversation on itself about movies is linked to the rating average, not the amplification and appreciation of the tweets involved. Lastly, the second week after the premiere date only shows tweet count, retweet count, and like mean as variables whose quartiles show a significant difference of rating average. This could lead to the assumption of a conversation with more retweets in total and an average of likes per tweet involved, being more important the amplification and an overall appreciation of the movie with time. On the other hand, only the number of theaters has shown a significant difference for the rating average, while opening grosses hasn't. An interesting combination because if the number of places where the movie can be seen affects the rating users will post, but not how many users have paid to watch it. Maybe it is more related to visibility and fame than the actual number of movie viewers. All these assumptions are strictly given by considering a few variables about the movies and the main characteristics of the Twitter conversation about them. This paper means to be a cornerstone to broader and longer studies that could confirm these relationships, prove new ones, and consider other new variables that could throw a new light into the matter. ANOVA has shown to be an interesting methodology to test significant differences in movies and Twitter data, which could lead to a trend analysis of the variables considered depending on the quartile of a certain data variable. Other studies could also consider other social media platforms such as Facebook and Instagram, which could enrich the perspective by considering the movie-related conversation in other formats or even a generic conclusion about all of them.